Okay, number 37 says the sum of two numbers is negative 23. How do I write that? Sum means what? Plus. So x plus y is negative 23. And it says their difference is 5. What does difference mean? Subtract. So x minus y is 5. Okay, and then we're going to solve it normally. What's the easiest way to solve this? No. Elimination. If we add the two lines together, what's going to happen to the y's? The y's go away. X plus x is 2x. Negative 23 plus 5. Negative 18 divided by 2. Okay, once you get x, plug it back in somewhere. Negative 9 plus what? Plus y equals negative 23. So if we add 9, we get negative 42. So on the test, I can't remember for sure. I might put like one of these easier word problems and maybe one of the harder ones on there both. Okay. I guess I'll help you guys set up 38 and then solve it on your own. Okay, Caleb, 11 is the sum of. Okay, what does is mean?
Doesn't that mean equals?
Yes.
So 11 is equal.
Okay, what does sum mean? Add. So sum of what? Twice a number and 3 times the second number. So the sum of, so we're adding, what are we adding? Twice a number. So what's twice a number? And 3 times another number. So it's looking like one of the problems from this chapter, right?
Yeah.
And then on the other one it says the second number. What's the second number? Well, the second number would be our y. Because we made up 2 variables for the 2 different numbers. So when they say the second number, that's what we call the y. The second number is, so what do I put for that? The second number is equal to, well, it says is equal to. The difference of, what's difference mean? Minus. What are we subtracting? 2 and the first number. So what should I put? What's the first number? X. The second number, which we called it y, is equal to the difference of 2 and the first number, which we called x. Okay, what's the easiest way to solve this one? Since we got an equation, boys, since we got an equation that says y equals, you can put that in for y in the first equation. That would probably be the easiest substitution. Okay, 39. I'm not going to give you time right now. You're going to have to go back and do it.
Yeah, sure.
Okay, on 39 it says the cost of renting the ice. So actually, as I read this one, I want you guys to try and write it out. See if you can get it on your own first. The cost of renting the ice skating rink is $200 plus $10 per skater. The cost of renting the roller skating rink is $300 plus $7 per skater. For what number of people would the cost be about the same? Okay, so the cost for the ice skating rink is $200 plus $10 per skater. How would I write that? $200 plus 10 per each times each skater. Okay, that would be, you could say that's equal to the cost, I guess, if you want to write it out as an equation. And then the other one is, what's pretty, almost the same thing, right? $300 plus $7 per skater. That would be the cost of that one. And they want it to where the costs are equal, basically. So this thing equals this thing. This thing up here equals this thing down here. Or you could think of it as like we're substituting this in right there. So 200 plus 10x equals 300 plus 7x. So what do I do when I have x's on both sides? Yeah, subtract off the x's from one side, match it on the other side.
That's nasty. That's nasty.
Okay, what is under divide by 3?
Decimal.
Okay, it said, now, the problem said about how many people would make the cost the same. It's not gonna come out perfect. Yeah, this would be like 33 and 1/3, or 33.3 repeated. So that's about 33 people. What color do you guys want me to use?
Black.
Purple.
Waffle. Waffle.
I probably need a lighter purple just to get your background.
Purple and blue. There it is, that right now. Waffle. Purple Kool-Aid.
Yeah.
Yes. Just go left.
Yeah, let's go. Let's go. All right. 40. 2 cars leave from the same location but travel in the opposite direction. Okay, boys. 2 cars leave from the same location but travel in opposite directions. First car travels, 50 miles an hour. What kind of problem is this? The arrow problems, right? So you need to start by drawing arrows. The 2 cars start same spot going opposite directions. So what should that picture look like? Yeah, start at the same spot, whoops, going in opposite directions. Oh, well, okay, and it says, so why don't you guys try and fill this in as I read it here. The first car travels an average of 50 miles an hour. The second car goes an average of 55 miles an hour. Okay, this next part is going to be tricky. The first car leaves 15 minutes before the second car. The first car leaves 15 minutes before the second car. That's a trick that we haven't talked about yet. So actually, before I keep going, let me mention that one. When we do speed, like 50 miles per hour, we're measuring it in hours, miles per hour. So when we do our time, we need to measure it in hours, just like we did on all the problems from yesterday, I guess. No, 2 days ago. So 15 minutes is how many hours?
15 minutes.
what fraction of an hour?
Oh. Yeah, like a quarter.
It's a quarter of an hour. So we could represent it as 1/4 or 0.25, but we wouldn't call it 15 because that would mean 15 hours. Because you measure speed in miles per hour. So we need our time to be in hours. So you can either use 1/4 or 0.25 when it says the first car left 15 minutes earlier than the other car. The one fact that I left out is how long will each car travel before they are 200 miles apart? So where does 200 miles go? Yeah. So that was all the info. Let's see if you guys labeled it correctly. 200 miles. I'll say this guy was the 50. Okay. And this, wait, was that their speed? Yeah, 15, 55. Okay, so I'll say the first guy on the left is 50, this one's 55. Okay, if this guy left 15 minutes early, he left a quarter of an hour early, would that be a quarter hour more for his time or a quarter hour less for his time? More. If you left early, he was traveling longer. Does that make sense? Like, let's say you and your friend both left for Tulsa to meet up, but your friend left 15 minutes earlier, who's been traveling for longer after the first, half hour. Your friend has been. So anyway, the first guy has been traveling for a quarter of an hour longer than this guy. So if I call the second guy's time t, I can call this one's t plus a quarter. So we didn't have that fraction in those other problems. Hey, boys, I'm about to move on here. Alright, what's the equation for this?
50 plus 55 equals.
Yeah. So one of the person's distances plus the other person's distance equals the total distance they're apart, right? Just like, that was pretty much every problem we did on that lesson. It was like that. Almost every problem. Is this an even? Okay. I guess I'll let you guys finish this one then. The question is, how long will each car travel before they're 200 miles apart? So you need the time. Now, you probably wouldn't put a fraction for the time, because we don't say travel for a third of an hour. You'd probably say like 2 hours and 20 minutes, or whatever. So just, anyway, you need both of these cars' traveling times. So t and t plus quarter, t plus 50 minutes. You need both of those answers. Okay, I guess I'll pause for a minute or two once you guys work on that one. And then the graphs come next. So you guys know where your graph paper is from yesterday?
Right here. In my hand.
Anybody lose their graph paper from yesterday?
So are the next four, they're all graphs? Yeah.
Okay. You didn't get that done, come back to it. See, I guess we need a graph paper here. Let's go.
There.
Let's go blue. And actually, let's. No, I didn't want to do that. There we go. That'll probably be enough. All right, 2x plus y is less than 6. And 2x minus y. All right, what's the first step for graphing this top inequality here?
Or the.
Solve for y, so I gotta subtract 2x, get y is less than negative 2x plus 6. So that means our graph's gonna have to go up to 6. And then on the second one, same idea, get y by itself, subtract 3x. So I get negative y is greater than or equal to negative 3x plus 4. What else do I need to do on that one?
You need to divide by negative.
Yeah, divide by negative 1. So when you divide by negative, all the signs and the inequality switches. So where am I going to start out for the first one? Up 6, and then from there,
Look down to.
oh, we switched to red. I don't know why they didn't make blue one of the standard colors. Go up 6, and then from there, go down to right 1. Okay, remember inequalities, 47 through 50, that's different than the equations that we did on 4 through 6. Oh, we only did number 5, but inequalities, you have to put solid or dotted dashed lines, or you have to shade above or below. So, should this line be solid or dashed? Dashed. Oops, that didn't work. Okay, it didn't work. And then the bottom one, we're starting down 4. And then we're going to go up 3, rise over run, up 3 over 1. And is that line going to be solid or dashed? Solid. Okay, this next part was the part that kind of gave us trouble on the last one, which is the shading. So notice there's kind of 4 regions that are created by the intersecting lines. Top, right, bottom, left. When we're shading, we're not really looking at the axes, the blue x-axis or y-axis, we're just looking at the lines here. On this problem, both of these inequalities are less than. So that basically means we need to go below both lines. So where would I shade below both lines at? Top, right, bottom, or left? Bottom. Everything in here is shaded in. What does the shaded region have to do with those inequalities? What does that have to do with anything? Any point in this shaded region, like 2, -3 for example, if I plug that in to both of these inequalities, it's going to work. Any random point you choose in the shaded region, if you plug it in both of these. So the shaded region represents all the answers that would work for these two. Now, back when we were doing equations, like on number 5, there was no shaded region. There was just one answer. The point on these lines, that is on both of these lines where they intersect, is the one solution that worked in both equations. On inequalities, there's a whole region, an infinite set of points. On equations, like equations are like equals, there's only one answer usually. That's where they intersect at. Okay, 49. Let's see. Let's go up here. Um, 3x plus 5y is greater than or equal to 12. And 2x minus 3y is less than or equal to 6. Alright, what's my first step to graph? Get y by itself. So I'm gonna subtract first. Then divide by 5. So where am I gonna write that out? I'll skip it. This is gonna be a kind of a mess, unfortunately. I'll put it over here, I guess. Y is greater than or equal to negative 3/5 x. Whoops. Plus 12/5. 12/5 that's the y-intercept, but it's probably going to be more useful if I change that to a mixed number. Do you guys know what that is? It's a mixed number. How many times 5 going to 12? 2 with the remainder of 2. So 2 and 2/5. Okay, then I got to do the same thing down here. Get y by itself. When you divide by negative or multiply by negative, the inequality switches. So this will be, where y is greater than negative 2 divided by negative 3 is positive 2/3. X negative 6 divided by negative 3 is positive 2. Let's start by graphing that last one because it'll be easier. So yeah, I'll start with this one. I'm gonna go up 2, and then, okay, so where am I gonna go from there?
Up to right 3.
Yes, up 2 and right 3. Or if you go backwards down 2 and left 3. And is that line solid or dashed?
Yeah.
Dashed, because it's greater than, not equals to. No, that does not work. Can learn to do a dash line on this. Gotta pick up your pen more. Alright, and on the other line, this one I was kind of worried about because the y-intercept is 2 and 2/5. Where would that be at?
It's like a little bit above the 2.
Yeah, 2/5. 2/5 is 2 is less than half of 5, right? So it's a little bit less than 2.5. So that's going to be about right from there.
You
Rise -3, run +5.
go down 3.
Okay, be careful on this one, because when we go down 3,
You have to go.
like if you go down 1, that's right there. It's still in between the lines. Down 2, down 3, over 1, 2, 3, 4, 5. So that's the spot right there. It's kind of in between lines. And if I go backwards, same thing. Up 3 would be 1, 1, 2, 3, 1, 2, 3, 4, 5. Okay, is that line going to be solid or dashed?
It's gonna be solid.
Solid. Okay, this one's kind of an easy, as far as the last shading goes. They're both greater than. That kind of makes it simpler. Yeah, if it's greater than on both of them, you're going above both of them. I think what gave us problems is like when one was greater than and one was less than. Let's pretend, just for practice, that it said greater than on our solid line and less than on our dotted line. Okay, if it's greater than on our solid line, then that would be up here, right? But if it was less than on our dashed line, that would be down here. So it'd be above the solid line, below the dotted line, that would be this region right here. But since it says greater than on both of them, it's above both of them, so it's kind of opposite of the last problem. It goes up here.
Yay.
Okay, I'm seeing 50, which is the last question. Number 50. It says y is greater than 2, which looks different than everything else on those problems. How do we graph y is greater than 2? How do we graph x equals, y equals 2?
So you go to the y-axis and go 2 and then draw a line.
Yeah, go to 2 on the y-axis and draw a line through it. Since it's y is greater than 2, that means it's not solid. And would that be, eventually, would you shade above or below that? Greater, y is greater than 2, that would be above. So don't shade though until the end. Alright, did you guys finish that, work on that, and then we'll be done with that.